In the last class, we had discussed introduction to the numerical methods, in which we are going to solve roots of an equation. The equations may be classified into two types. One is called polynomial equation, another one is called transcendental equation. An equation is said to be polynomial if it is in the form of polynomial of degree from n. And an equation which is called transcendental equation, if the equation involves trigonometric functions such as sin x, cos x, or exponential function like e power x, or logarithmic functions, etc. These are called as transcendental equation. Now in this class, we are going to find the roots of this type of equation. By a root, we mean an value a. If you substitute this value a in the equation f of x equal to 0, and if it is exactly 0 or it is nearly 0, then it is called as the root of the equation. First, we are going to discuss about bisection method. The bisection method is one of the closed methods or bracketing method to find the roots of nonlinear equations like polynomial equation or the transcendental equations. The principle behind this is to find an interval in which the root lies by substituting the values x equal to 0, 1, 2, 3 successively, so that we find the sign change between the two values. If there is a sign change between the two values, then there is a root between the two values. This is by the theorem. An equation f of x equals 0, where f of x is real continuous function, has at least one root between xl and xu if f of xl into f of xu is negative. It is f of xu may be positive, f of xu may be negative, so the product is negative, or f of xl is negative and f of x is positive, so that this will be less than 0, or these are all of opposite signs. F of xl and f of u is opposite sign. If this is positive, this is negative. If this is negative, this is positive. So if we draw the curve like this, where it crosses x-axis is called the root of the equation. Means if f of x and f of xu is greater than 0, then there may or may not be root between the roots between xl and xu. But if it is negative, then there is at least one root between xl and xu. For this, suppose consider the examples in which it changes from negative to positive. It crosses x-axis here. So this is exact root. So between this origin and xl, there is a root. Similarly, between xu and this point, there is another root. So in this way, we can find out if you draw the curve, the curve changes from negative to positive or positive to negative, then there is at least one root between these. Here, there will be more than one root. This is one root, 2, 3, 4, 5 roots. For this kind of equation, there will be 5 roots. But from this method, we can find it only one of the roots of the equation. I'll discuss how to find the roots of the equation by bisection method. So this is the algorithm behind bisection method. In this method, we first to find out the lower limit, upper limit, so that the product is negative. Or in other words, f of x changes sign between xl and xu. here it is f of xl is negative, but f of xu is positive. So there is root between xl and xu. This is our exact root. And in this method, we divide the interval into two intervals, and we take it as approximate root of the equation xm as xl plus xu by 2. So this is the initial approximation of the root of the given equation. Next, we find out the sign of f of xm. If f of x, now we find that f of xm f of xm is negative and f of xu is positive. So the root is lies between f of xm and xu only, not between xl and xm. So we omit this interval. Every time we divide the interval into half and omit one half of the interval. So here we omit xl between xl and xm, and we take this as the new approximation. Again, we take the next approximation as xm plus xu by 2. So in this way, every time we are reducing this into half, so that finally we get the solution. Now we check the f of xl, f of x means negative. The root is between xl and xm. If f of xl, f of xm is positive, the root may be between xm and xu. So and if f of x exam is exactly 0, then the root is obtained, that is, we can stop the process. Otherwise, we repeat this process until two success values of difference between two success values will be less than or equal to the desired accuracy. If we want 4-digit accuracy, then XL difference between two success values must be less than or equal to 0.0005. So the absolute error will be maybe this epsilon A equal to xm mu xm volt by xm mu into 100. This is called the absolute relative error. And we compare the absolute relative error epsilon A with pre-specified error tolerance limit, 4-digit or 3-digit or 4-digit limit. If it is less than tolerance limit, if it is we go to this step. Otherwise, if it is no, if it is greater than if it is greater than, then go to step 2. If it is less than, then go to stop the algorithm. Now we take an example. Find the root of the equation x cube minus 9x squared plus 18x minus 6 equal to 0. Now we find that if you find the sign between the put x equal to 0, if you put x equal to 0, the value is negative. So f of 0 is negative. If you put x equal to 1, it is also still negative. And there will be the root is between 2 and 3. When f of 2 is negative, the f of 3 may be positive. So we can take the approximate root as 2.5. So to know how many iterations it is going, we can use a formula xm minus p is less than or equal to upper limit minus lower limit by 2 power n, where n is greater than or equal to 1. Now we have identified that the root may be less than 2 and 2.5, the accuracy level 10 power minus 3. So you find that the substitute these values here, we find that n should be greater than or equal to 9. So this step requires at least minimum of 9 iterations for convergence. Now step 1, we have first assumed that the root is between 2 and 2.5 because f of 2 into f of 2.5 is negative. Otherwise, there is a sign change between 2 and 2.5. It is f of 2 may be 2, f of 2.5 may be minus 6. So the root is between 2 and f of 2.5 is minus 1.625. So we got that the root is between 2 and 2.5. Now we estimate the initial approximation as 2 plus 2.5 by 2, which is 2.25. So in the next step, we repeat the process with XL equal to next 2.5 and at 2.xu, xm is 2.25. Now we are going to identify the root is between 2 and 2.25 or 2.25 and 2, for which we have to find the sign of f of 2.25. Now we find that f of 2 is 2, f of 2.25 is 0.38. So this is positive. So the root is between x and xu. So root is between 2.25 and 2.5. So next approximation is 2.25 plus 2.5 divided by 2, which is 2.375. Now in continuing in this manner, we verify whether the root is between 2.25 and 2.5 or 2.5 and 2.3725. For this, we find the sign change. F of XL is 0.38 and f of XM is negative minus 2.38. So the root is negative. So the root is between 2.5 and 2.25 and 2.3725. So continuing in this way, we repeat the process for 9 steps. Can we find that the difference between the two successive value will be equal to 0.000005. So whenever the earlier difference between two successive values of x is 0.0005, we can solve the process. This is the root. This is the root of the equation, approximately up to 5 digit or 4